Imagine a farm. What do you see? A farmer, rice, onions, vegetable crops, carabaos, chickens, goats, cows, and machineries. Agricultural farming gives benefits to humans in terms of food supplies, like rice, grains, milk, and meat. Things that we usually see inside in our fridge and on top of our tables as we eat our meals. These elements are arranged linearly, as in a factory. However, the farm produces many unwanted elements that are difficult to control. Much like humans and other ecosystems, a farm can be seen as a complex organism whose organs depend on each other. This is just what the agroecosystem is. An agroecosystem, or agricultural ecosystem, is an ecosystem managed by humans to grow crops and to take care of animals. Agroecosystems account for 30% of the Earth's surface. It is an ecosystem in which humans have intentionally chosen the biota's composition or the crops to grow and the animals to take care of. It provides various ecosystem services such as production of food, fiber and fuel, soil structure and fertility enhancement, nutrient cycling, water provision, erosion control, pollination, and pest control. It has also management practices, all of which are human-made and focus on a long chain of experience and experimentation. Agroecosystems may be classified as plant and unplant diversity. In plant diversity, farmers intentionally include a spatial and temporal arrangement of domesticated plants and animals in the system and beneficial organisms that are deliberately added. Unplant diversity, on the other hand, includes weeds, herbivores, pests, microbes, and other species. These species continue to live in the environment after being converted into agriculture or after being colonized from the surrounding landscape. The productivity, stability, pest control, soil processes, and movement of species between agriculture and natural ecosystems in the agricultural landscape are highly influenced by plant and unplant diversity. Among Earth's ecosystems, agroecosystems are the most intensively controlled, also the most disrupted. Many of the natural ecosystem features of agroecosystems are preserved. However, from a toxicological point of view, though being modified for food and fiber processing, they are distinguished by agrochemicals' regular presence, including fertilizers, pesticides, and plant growth regulators. However, agrochemical pollution's type and degree vary considerably, depending on the crop's and livestock's nature. Due to most agroecosystems that are more regularly disrupted and more intensive than natural habitats, there has been a decline in biological diversity. Approximately 50% of global arable land is now under mechanical and chemical intensive cultivation, which requires high inputs of nutrients, energy, and water. Our challenge now is to decide how to increase output while preventing deterioration or depletion of resources. In order to find a balance, the agricultural production method must consider environmental factors. This includes modifying modern agricultural methods, shifting as far as possible away from external inputs. In the same way, we do not take medication when we are well, using inputs periodically in a targeted way rather than routinely, enabling autonomy and circular logic to increase agricultural productivity, biodiversity, pollination, water quality, and soil fertility. A balanced agroecosystem is self-sustaining, capable of creating and preserving a variety of ecosystem services. The aim is to build more ecologically planned agricultural systems that will reintegrate traditional agricultural knowledge features such as soil conservation, biodiversity-based farming, and by introducing new ecological knowledge, practices, and technology such as integrated pest management, organic farming, and use of biopesticides and botanical pesticides, and introduction of new technologies such as monitoring of pests and diseases using remote sensing, and smart agriculture or smart farming for food security and sustainability as well as for climate change adaptation and mitigation.